Now let's come to the solution of question 2 in homework 11. Homework 2 asks us to find out which functions of Fv may represent each may represent an autocorrelation of a autocorrelation function of a WSS stochastic process or a spectral density functions. First, let's have a look at the choice A. Fv equals is minus absolution of V's power of E. It can, at first, we have to state that it can represent an autocorrelation function because when R of tau is an autocorrelation function of a real WSS stochastic process x of t, it will meet the requirements that it's an even function and R of tau is less or equals R of 0 and its Fourier transform is non-negative. Obviously, the function Fv of this meets these three requirements, that is minus absolution of V's power is even and and this is less or equals when V is equals 0 and its Fourier transform is non-negative, so it may represent an autocorrelation function. Well, it can be represent a power spectrum when it can represent a power spectrum function. It will have to meet the requirements that it should be non-negative. Obviously, this expression cannot be less than 0, so it may represent a power spectrum function. Now let's come to the second choice. It can represent an autocorrelation function because it also meets the three requirements, that is, itself is an even function and the value of the itself is smaller than 1 and its Fourier transform can be drawn out like this, and obviously it is non-negative, so it may represent an autocorrelation function. When it comes to whether it can represent a power spectrum, the answer is yes, because the function itself, sine omega square divided by omega square is larger than 0. When it comes to the third function, we can find out its Fourier transform is 2 multiply sine alpha omega divided by omega. This one is not a non-negative function. That is to say, it doesn't match the third requirement. So it cannot represent an autocorrelation function. But looking back to the function itself, it's obviously larger than large or equal is obviously larger or equals 0, so it may represent a power spectrum function.